Hi, good morning. In Unit 7, today's lesson is about wave superposition. But first, we're going to do our bell ringer in the next slide. So, if you're watching this in your computer, put pause and do your bell ringer. If it's in person, follow the instructions.
Okay, now I'm going to show a video of a demonstration of wave superposition. And when you watch the video, please write 2 sentences on what you think wave superposition is based on this video.
Okay, for this demonstration, I have my able assistant, Parker. Parker, smile at your admiring audience. And we will be demonstrating transverse standing waves. I'll also demonstrate traveling transverse waves. Here's a traveling wave. I'm starting the wave by creating a disturbance here with my hand that is perpendicular to the direction of propagation of the wave. So I'll move my hand up and down, and you'll see that the little bump in the spring travels from me to Parker and then back to me again. And you'll notice that when the wave hits Parker's hands, because he's holding it firmly, what was a peak heading toward him converts itself into a valley as it bounces off of his hands. So then a standing wave is where you pick a frequency that matches the length of the string in such a way that the waves created from my side of the string and bouncing off of Parker's coincide with each other and reinforce each other to create a standing wave pattern. The lowest frequency standing wave pattern is this one. It's called mode, M-O-D-E 1, or the first harmonic, or in other words, also called the fundamental mode. It's the lowest frequency mode that you can get in a transverse standing wave. If I double the frequency of that mode, I get the second harmonic, or second mode, and sometimes called the first overtone. And this one, if you'll notice, is going twice as fast as the fundamental mode. It has a node that's exactly halfway between Parker and me. And that's a node where there's approximately no motion going on. 2, 1, 2. So now I'm going to try and triple the frequency and get a standing wave pattern that coincides with the third harmonic or second overtone. Let me try again. Okay, I think I've got it approximately now. I think I had it for a little while there. That's the third mode, where the string vibrates in 3 separate segments. There's actually an infinite number of these modes that you can get, and see if I can get one of the higher modes. I think that's 4. And then if you're really, really good, you can get 5, 6, 7, 8, etc. So notice that with each mode, there's a particular frequency that I have to vibrate at in order to create that mode. There's a one-to-one correspondence between the modes and the frequencies. That's standing waves.
So after watching this video, if you're on Schoology, please pause and write down 2 sentences on what you've learned about superposition.
Once you have written down your 2 sentences, if you're watching along, pause the video and copy down this definition. So basically, wave superposition is when 2 or more waves overlap and combine to form a new wave, where the height of the new wave is the sum of the heights of the overlapping waves.
Okay, so now we're going to show you a simulator on how waves interfere. So this website shows you can make the waves have a positive height or negative height, and you can make them have many different amplitudes. So first, we're gonna have two waves with two different size amplitudes, but positive heights. So if you're watching this online, please pause the video and think about what's gonna happen when these two waves interfere. So when these two waves interfere, you can see that they combine and they create a longer amplitude when they meet in the middle.
Okay, so now we have one wave with a negative height and one wave with a positive height. If you're online, please pause the video and write down how you think these waves are going to interfere.
So when these waves go, as you can see, they cancel each other out and almost make a straight line when they pass through each other, because one is a negative height and one is a positive height.
And now we're going to be explaining the different examples of waves. So please take a moment to pause this video and write these down in your notebook. Okay, so first off, destructive interface occurs when opposite faces meet. This happens when the waves meet at the exact same peak. And when it doesn't meet, it reduces the amplitude, making them cancel each other out. So in the image for destructive interface, you can see how the amplitude is basically the same, but they're going in different directions, making them cancel out.
The next wave interface is constructive interface. This is when the wave have the same phase and meet. The waves peak reach the same time. This causes the waves to have a longer amplitude because they combine.
Okay, so now I'm going to be showing you guys question number 8. So the question reads, the figure shows two wave pulses that are approaching each other. Which of the following best shows the shape of the resultant pulse when the centers of pulses point P and Q coincide? If you're watching this on Schoology, please copy down this word. If you're in person, please copy down as I write it down. So there's a peak on this wave, and when you're combining the two peaks, they both have the same phase, which means that they reach their peaks at the exact same time. So when you're combining them, the top two peaks reach at the same time, which means they combine and create a larger amplitude like we saw in the simulator. And the bottom one cancels out. And this creates the answer of answer number 3, because there's no bottom one and the top wave is double the height.
Okay, so for quest number 9, first you need to pick one of the spots in the middle because that's when the two waves are going to converge. I chose to do number 3 because on the left of the 0, it's moving at 1 meter per second, and on the right, it's moving at -1 meters per second. So what's at 0 right there will be at 3 by the time we're supposed to be observing it. So at 0, the wave has a value of 0, but then to the right, since it's moving to the right, I need to add 3 more, and that's what's going to be there at that time. So what is at number 6 is what's going to move to 3, which is the light blue dots. And so it's going to be at 0. So it's going to be 0 plus the -2, that's at 6. So I know at 3, I'm going to need a value of -2 for the amplitude, which is the dark blue and the light blue. So if I check all the answers, I see that the only answers with a value of -2 at a distance of 3 meters are 2 and 4. So then I'm going to check the next spot, number 4. So for here, I need to go back 3. So it's at -2. And then I need to go forward to 7, which is at 1. So I'm going to add those two together and I get -1. So now I need to check which one is at 4. So which one at 4 is -1, which is the red. And the only answer choice is number 2.